Okay, hello, Chem AP students. I'm Mr. Hevel,
And Mr. Moore.
and today we're here so that we can videotape your first lab. Okay, but we got to give you some background so you have an idea what's going on. So, I believe this reaction that you're going to use involves a double replacement reaction.
Double replacement reaction. You remember what that is?
If you don't, go look it up. Okay, and because we're going to make a precipitate for this reaction, we can capture the precipitate on a piece of filter paper. All right, and we have to show you a new lab technique that we use to help that along. Okay, so the College Board would refer to this as gravimetric analysis. Okay, we're going to use the mass of the precipitate to help us calculate something.
Sounds good. Yep. So what kind of equipment do we have for gravimetric analysis?
Yeah.
We have one of these. A normal flask is not quite normal. It has this sidearm on it. So you can, we'll do something with that. There's going to be a funnel that has a stopper that it's going through so that we can make a good seal between the funnel and the inside of the flask.
And we have a piece of filter paper, again, that will be in the funnel to capture our precipitate. And if we did this using gravity to pull the water through, it would take a long time. And Mr. Moore has a lot of patience. I couldn't wait that long. So we're going to use something called suction filtration.
Yep.
And I don't know if they can see it because we're a long ways away.
Yeah.
On the faucet, there's a device called an aspirator, and it's what's going to generate the suction force. So let me just show you real quick what's going on there. So if we turn the water on, the water rushes through the nozzle, but it pulls air through this sidearm. And you can tell that because when I plug it up, the water slows down. Okay? So the idea is we're going to hook this heavy-walled vacuum tubing up to this sidearm, and we'll connect it to the flask.
So that creates a vacuum? That's pretty
does.
cool.
Yeah, here, we'll check it out. Here, let me take the funnel off for a second.
Yep.
If I turn the aspirator on, put my hand over it,
I can hear it. Yeah. Oh, how nice.
yeah, you hear the popping noise? Yeah. So we can generate vacuum, and that will help draw the water through so we don't have to wait as long.
Doesn't that waste a lot of water, Mr. Hevel? What about the fishies?
Well, you know, it all goes back to the same place. It's going to go down the drain
Oh, okay.
and go out to the lake.
Okay, all right.
And chemistry is more important than anything. So
Absolutely it is.
the fish will figure it out. Okay, so let's show you what a difference it makes, though. And I wish you were here live to be able to do this, but we have to put the piece of filter paper in the funnel and get it to seal tightly. And so we'll fold it in half once, fold it in half twice, and if we pull 3 of the 4 edges together, we get a nice
Oh,
cone
yeah.
shape, and that'll fit inside that funnel tightly. So normally what I do,
We use a little water to
Oh, yeah, there we
help
go.
that stick. We wish you were here for
Yeah.
this. You need to be doing all this yourself.
yeah, so usually I soak the filter paper down and I press it tightly into the funnel. We want a good seal. We don't want any air rushing behind the filter paper because then we lose suction power. So if I put some water in here, okay, I don't know if you can see this, the water dripping through. I don't know how well it's showing up. If I put my hand back there, can you see the water drips coming through? Notice the rate they come through. It's not real quick, and once you get precipitate on the paper, it starts to plug it up, which slows it way down. But now watch, I'll turn on the vacuum,
Wow,
and all of a sudden, pow, the water just gets pulled right through. Okay, it speeds things up quite a bit. Okay, so that's suction filtration. We're using this technique to help us capture the precipitate that the reaction generates.
And it goes a lot faster with the suction.
Yeah.
We can't stress that enough. We would be
Yes.
sitting here for a
For a
long time. Yep.
Yes, it would not be good. Okay. So let us tell you some more information. What, did we forget anything there?
I think, no, that's going to get us our precipitate, and we'll filter everything that's dissolved right through the paper. The paper
Yes.
only catches the solid
I did say that.
precipitate, and everything else goes through.
Right, anything that's aqueous runs through the paper.
Yep.
Yep.
So should we talk
Yeah.
about the specific lab?
Yeah.
All right.
You want to stand or you're just gonna?
No, I'm just going to hold it.
Okay, so there's a little bit of information you need. Last year, we used solubility a little bit, but it's important to know this. These ions are always soluble. Group 1 metals, the ammonium ion, and the nitrate ion. You need to know that, okay? Here's what you're going to get. You'll see this in a minute. We mixed 2 ionic compounds together. There's potassium chromate and barium chloride, right? They're both solids. We mixed them together to create the sample, okay? Another very important item to know is that potassium ions, barium ions, and chloride ions are all colorless in solution. But the chromate ion looks yellow. It's a very noticeable yellow color if it's present in solution. Okay? So what's going to happen here, and you'll see this in a minute, we have a sample that has these 2 solids on a piece of paper, okay? Essentially, we're going to dissolve it in some water. The double replacement reaction will happen. A precipitate will form, and then we're going to filter out that precipitate. Okay?
Yeah, double replacement, remember, the positive ions switch places.
Something like that. I get confused.
Yeah.
Yeah.
I'm just trying to work that out in my head.
Yeah. I mean, you haven't done this in a year, so.
It's been a long
I
time,
forget,
yeah. Okay, so that's what we're up to. Let's see, there's already a sample that has been measured out
Yes,
and
there
waiting
is.
for us.
Yep. Normally, if you were here, you would get every lab group would get his very own sample to use. And so, Mr. Moore and I are the lab group now.
We'll see how we can botch this up
Yeah.
for you.
Oh, and we will. Okay. So here's the sample. I don't know how well it shows up at all. Not this way. So on the piece of paper.
Yeah, you know what, I can tilt this down. See it.
Yeah. I think, oh, now we have a ton of glare. You
Okay.
can't see anything, I don't think.
Ah,
Okay.
there it is.
There
There's
you
the
go.
sample.
Okay, there's the sample. Okay, again, it's the potassium chromate and barium chloride mixed together on this piece of paper. Okay? Now, it's probably important for us to know the mass of this sample to start with.
Yeah, we
Okay?
probably ought to know that.
Probably ought to know that. So we got a balance here, a scale.
We're going to dissolve that sample in water, so we'll use a beaker. Put the beaker on the balance.
Should we move it over
Yep,
closer?
I'll bring it over.
I can move this.
That's all right. Well, I'll need to pick this up to be able to see the mass on there.
Oh, I guess so. Okay, so here's the beaker.
Yep,
We
that
use
mass
it.
doesn't matter so much. We'll just zero out the balance. And
Okay, so here we go. We're going to need to know the mass of our sample. So we're going to put an empty clean beaker on the balance and zero it, so we can get the mass of our sample.
there's that.
Okay, that's a good number.
Yep.
All right, now remember, double replacement reaction occur aqueous, so we're going to add some water to this. Get our sample to dissolve.
hard to tell it dissolves because a precipitate is made right away from some combination of the ions.
Yeah, it looks pretty
It's
cloudy.
Cloudy.
Okay, so recall gravimetric analysis is really what we're using here. We'll use the mass of the precipitate to then help us calculate some other factor that we'll ask about later.
Mhm.
Okay, so this is ready. We got to get our filtering set up ready to go. So we'll grab a piece of filter paper. There's a funnel.
Yeah, we might need the mass of that filter paper. That's probably
Oh, come on,
good.
Mr. Moore.
Well,
What could it matter?
Let's
Well,
take it. Let's
Mr.
take
Moore's
it for kicks.
usually right, so I'm going to trust him. Well, let's get the mass of our filter paper.
All right.
Got it?
Got it.
Okay. All right, so here we go. We did this before. Same maneuver. We'll fold up our filter paper. Put it in the funnel. We want to make sure it's going to stick to the funnel, so we're going to wet it down. Make sure it's stuck to the side. Okay. And you can see gravity pulling the water through. And I'll
Yep.
gently turn on the faucet. And get that suction started.
Like that. Yep.
And I think we're ready to start. Okay, so we're just trying to carefully pour from the beaker into our flask. We have to be careful. We don't want the fluid level in the funnel to get above the top of the filter paper, because then it runs behind
Right.
and you'll lose some of your precipitate.
It's a really common mistake.
Yep.
Both of our students make that you want to just pour the liquid all the way up to the top of the funnel to get it to go faster, but then some of the precipitate runs behind the filter paper
Yep.
and you lose it.
Classic error.
So we'll just keep doing this
Yep.
until all that liquid in the beaker is gone.
It's not unusual for this to take a group the entire class period.
Right.
You just have to be patient.
Let's take a look at this filtrate. The filtrate is the liquid that goes through the filter paper. Yep. Note the color.
Color could be important. We're hoping the filtrate stays nice and clear. You don't want to see any precipitate down there.
Yep.
It could have color, that'd be okay, but we don't want to see cloudiness.
Okay, we're now down to the bottom of the beaker.
Yep,
We've rinsed it a
nice.
couple of times with the wash bottle.
Yep, not much left. So again, the quality of your answer depends on getting all of that precipitate out of the beaker and onto the filter paper.
Yep.
So pretty,
All right.
pretty good. We always pointed out the color, didn't we? The color?
Yeah, we sure did. Take a look again at the filtrate. You'll see why later.
Yep, I'm gonna give a good rinse here, one final good rinse. Okay,
Yep, we're right at the top of the filter paper there.
Yep.
So we're just going to let that filter all the way through, the rest of the way, and set it out over the weekend. So it can completely dry and we can get the mass of the precipitate.
yep,
Here's our sample in the filter paper that after it has dried all weekend. It's been 3 days now that we have been letting it sit there. Paper from being wet has curled up like that. Our precipitate has made a thin coating inside of the paper. And we need the mass of that. So here's our balance. Filter paper plus the precipitate has that mass.